What's going on, everybody? Miss Berry here again. We're moving into the second unit and we're talking about quadratic functions, moving away from piecewise functions and absolute value functions, dealing with quadratics. So every single time we have a function in this unit, we're talking about seeing an exponent of 2 at some point in time. And what I want to talk about in this video is we're not going to dive too deep because this whole unit. We're going to spend time with these 3 different ways to write the same exact thing. So I can't stress this enough. The 3 things I have up there in the blue you can see is standard form of a quadratic function. We've got y is equal to ax squared plus bx plus c. We have the intercept form for a quadratic function. Y is equal to a times the quantity x minus p times the quantity x minus q. And then finally our vertex form, y is equal to a times the quantity x minus h squared plus k. Those 3 things say the same exact thing. Alright, so we could have problems, and we will have problems, where you'll be provided all 3 of these things. And the idea that we're going to really hit on here in this unit is understanding why and how we would use each of these specific ways to write things out. So a very, very quick explanation to things that we're going to see an awful lot here in this unit. Let's go ahead and start off by talking about standard form. Y is equal to ax squared plus bx plus c. That right there is the most simplified way to write out a quadratic function. Now I say simplified because if you look at this in the green, you might say to yourself, well, that looks like there needs to be some sort of distribution or FOIL. So if I was to simplify the green and do the math work on the green, I could still multiply a bunch of different things on that. The same with the red here. Something's being squared, and when something's getting squared, it's just multiplying by itself twice. So for both green and red here, to have the most simplified way, we would still have to do some sort of multiplication. Standard form, everything's written out. There's nothing operationally to do with. So when the times that we use standard form, we use it mostly because it's the most simplified way to write a quadratic function. So this is the most simplified way to write a quadratic function. I'm going to abbreviate quadratic a lot in this unit, so quad right there. We're not talking about anything from geometry there with pictures and quadrilaterals. It's a quadratic function. The intercept form, and I guess I should start off by saying this, the next 2 are very, very, very specific on what it is that we would most want to use them for. The intercept form is very, very blatant in that, and it's because this right here, if we have something in intercept form, straight up right away gives us the intercepts for a problem. And when we're talking about intercepts in this case, you can kind of see right here, we have inside these parentheses both times in each of the parentheses the letter x. So we're given in intercept form x-intercepts. Right off the get-go, not too much to think about. If something's written in intercept form, we're mainly using it because it shows us right away where the x-intercepts are located. And obviously there'll be more videos on that and the importance of that, highly, highly applicable in that scenario. Finally, and we've heard this word before and we've heard it plenty of times when we were talking about absolute values, is vertex form. And as you can imagine, vertex form, well, straight up, it gives us easy appearance to pick out where the vertex would be located. Alright, even when we look at that, coming right off of absolute value functions, you should hopefully notice in the red here, you have an a, you have an h, you have a k in the problem, very similar to absolute value functions. So that provides us with the information, and we know that if we have a vertex, well, we got a lot of things. We got a vertex, we got a max or min, we got an axis of symmetry, that come from that vertex. So again, we're going to take a lot deeper of a dive on each and every one of these individually, not only the algebra behind it, but also the applications. But we got to realize that there's three different ways to write one specific thing, and that's a quadratic function, with this whole unit and these next two units are on.